Welcome back to The Explainer. Today, we're jumping straight into Lesson 6 of our Enterprise Machine Learning series, and we're focusing on something absolutely crucial, building a centralized command center for enterprise ML ops. If you're scaling machine learning across an organization, well, this is the architectural blueprint you literally need to maintain control, visibility, and, honestly, your sanity.
So picture this reality for a growing enterprise. You don't just have one data science team working in a single environment anymore. You've got multiple teams, probably spread across totally different business units, operating in 50 or more isolated cloud accounts. Now, suddenly someone reports a failed model training job. How exactly do you track it down? Are you really going to log into account number 1, check the logs, log out, and then move to account number 2? You're probably just drowning in browser tabs and trying to manage some endless spreadsheet of credentials. It's a chaotic, exhausting reality for MLOps engineers and cloud architects. And as organizations scale their ML operations, these dispersed resources naturally create massive visibility and governance bottlenecks. Think about it. Siloed environments basically equal blind spots. If you've got data scientists building and training models in isolated pockets of your cloud infrastructure, you can't effectively secure those workloads. And just as importantly, you can't optimize them. You simply can't manage what you can't see, right? Which brings us to a really powerful directive straight from our source architecture docs. This is a totally non-negotiable mandate from the Chief Information Security Officer. No account is outside the monitoring perimeter, period. This sets the absolute stakes for the architectural build we're exploring today. Every single log, metric, and deployment event literally must be forwarded into the enterprise detection and response workflow. Okay, so here's our roadmap for today. We're going to start with the scalability challenge, introduce the hub and spoke architecture, dissect the data flow, check out the single pane dashboard, and then wrap up with some essential benefits and best practices. Let's get into it. All right, let's dive right into this. Section 1, the scalability challenge. When a company decides to adopt machine learning, they usually start off in a pretty decentralized way, and that leads to a very specific type of technical debt. According to our MLOps design breakdown, the absolute biggest enterprise failure mode is local optimization. This happens when every single team builds in total isolation, choosing their own repos, their own branching models, their own deployment styles, and basically hiding their metrics within their own specific accounts. To fix this mess, we have to swap out that local optimization for true enterprise control. We need standardized release paths across all ML teams, and crucially, a unified monitoring view. Which leads us perfectly into Section 2, hub and spoke architecture. So how do we physically build that unified view in the cloud? Well, the hero solution that solves this isolated AWS account problem is the hub and spoke architecture. Imagine a wheel. The spokes are your multiple isolated workload accounts. This is where your data scientists are out there actually using Amazon SageMaker to build and train models. But here's the catch. All of those accounts are required to stream their events over to the hub, and that hub is one central monitoring account. It's a single account completely dedicated to capturing and visualizing the activity from every single workload account in the entire enterprise. Now, the magic that makes this connection possible is a brilliant feature called cross-account observability. It's an Amazon CloudWatch capability that acts as the real foundation for our centralized command center. It fundamentally changes the game. It allows your central monitoring account to search, analyze, and view metrics, logs, and traces across all of those separate workload accounts, seamlessly tying the hub and the spokes together. Let's keep moving. Section 3, dissecting the data flow. Let's move to and see how this builds by de-jargonizing the actual mechanics of a machine learning event. Step 1, an event happens in a workload account. Let's say a SageMaker training job changes its status. Boom, that's captured by an event bridge rule. Step 2, that raw event is instantly streamed over to the central monitoring account's event bus. Step 3, the event is intercepted and processed by an AWS Lambda function. And finally, Step 4, that Lambda function converts the raw event data into usable CloudWatch metrics. It uses something called the embedded metric format, which basically acts as a translator to turn raw system logs into readable numbers. If we zoom in on that specific interaction, you can really think of Amazon EventBridge as the traffic cop. It's standing there, receiving these raw events from all over the organization and routing them to the exact right place. Then, think of AWS Lambda as the translator. It grabs those raw system-level events and augments them, translating the data into readable metrics that a human engineer can actually sit down, look at, and understand. Moving right along to Section 4, the single pane of glass dashboard.
all of this complex plumbing we just talked about, the cross-account roles, the event buses, the Lambda translators, it all builds up to this visual reward. This is the payoff. Now, what's really interesting about this setup is how instantly an engineer can spot a spike in failed training jobs across the entire enterprise. You aren't guessing which account is having trouble anymore. The dashboard aggregates the whole shebang. You can immediately see the account ID, the job name, the duration, and the exact failure reason all lined up in one super clean interface. Let's detail these specific metrics you absolutely should be tracking here. First up, job statuses. You need to see total versus failed processing and training jobs right at a glance. Second, job history. We're talking about tracking the duration, the specific instance type used, and the account origin. And third, resource utilization. Guys, this is absolutely critical. Tracking CPU, GPU, memory, and disk usage isn't just about system performance, it's the absolute key to identifying costly bottlenecks. I mean, if a team is out there requesting massive GPU instances, but they're only utilizing 10% of their memory, you are just burning enterprise capital. And this dashboard, it'll tell you exactly who's doing it. All right, final stretch. Section 5, operational benefits and best practices. So why does all of this actually matter for your daily operations and ultimately your bottom line? Well, the operational benefits are massive. First off, you're going to save your engineers countless hours because they can troubleshoot centrally without ever needing to log into individual workload accounts. Second, you save the enterprise some serious money because you can finally analyze resource utilization globally to optimize those cloud compute costs. And third, you can easily support strict governance and compliance audit requirements simply because every single action is logged centrally. You've got a perfect paper trail. But, and this is a big but, to get those benefits, you have to follow best practices. Actually, scratch that. A dashboard is literally useless if no one is looking at it, right? So you must set CloudWatch alarms to proactively notify you of critical job failures. Make sure you configure your alert thresholds based on historical performance baselines. You also want to implement strict identity and access management, or IAM policies, basically ensuring auditors have read-only access to this central hub. And finally, please use consistent naming conventions for metrics across all your accounts. If you don't, your beautiful dashboard is going to turn into an unreadable mess of conflicting data labels for sure. So the crucial takeaway here is that building a centralized command center isn't just some fun technical exercise. It is a fundamental requirement for maturing your MLOps practice. I want to leave you with a provocative question to take back to your own organization. Is every one of your enterprise ML workloads safely inside the monitoring perimeter? If the answer is no, or honestly, if you aren't completely sure, then you have blind spots, and it might just be time to start building your own hub and spoke foundation. Thanks for joining me for this explainer, and I'll see you in the next lesson.